Hello, I'm Dr. Chris Thompson, and this video is intended to help students getting started programming and problem solving with Python. It's an introductory tutorial and it involves you undertaking some problem solving yourself, and I will go through solutions with you. It was originally based on some face-to-face material that I developed some years ago and worked well in the classroom. However, due to changes in teaching, it's not something I've been using lately. So I thought I would create this as a self-paced video so that you could still make use of the material and use it to practice your problem-solving skills. First of all, I'm going to, for each question, I will briefly introduce it to you in this video, but there's also a handout that you can download that you can study separately if you prefer. After introducing the question, I'll then talk through the solutions and how I went about creating them. My recommendation is to have a go at the problems before you look at the solutions. When you download the handouts, you'll find there are solutions included with them there. So this is very much about you working around this material in the way that suits you the best. Here's where you can find the material. I've made available both this set of slides and the handout with questions and solutions as separate downloads that you can obtain straightforwardly. Because that handout file contains some Python code, you might occasionally find that your virus scanner will tell you there is a virus in it. As far as I know, at the point of uploading, there was no virus included with those solutions. The questions are based around the idea of using problems from Project Euler. Project Euler is a really great place you can go to find practice questions that you can use to hone your own problem-solving skills. So I felt it was useful to grab one of these and discuss about how I might go about solving it. And then if you want to practice further beyond the material presented here, you may well go to Project Euler and look at some of the other problems there. The problem I've selected is about palindromes, and it's problem 4. A palindromic number reads the same both ways. The largest palindrome made from the product of 2-digit numbers is 9009, and that's 91 times 99. The question is to find the largest palindrome made from the product of 3-digit numbers. Now, analysing this problem, the first thing that will come to mind is, what is a palindrome? Now, there's an example here, but it doesn't really explain what a palindrome is, so we need to go and look that up. And the most straightforward place to look for these kind of things is to pop along to Wikipedia and see what's there. So on Wikipedia has the definition of a palindrome, last checked by me in 2015. A palindrome is a word, phrase, number or other sequence of characters which reads the same backwards or forwards. Allowances may be made for adjustments to capital letters, punctuation and word dividers. Famous examples include a man, a plan, a canal, Panama. And if you look at that, you'll find that it has the same letters forwards and backwards. Amor Roma, race car, stat cats, step on no pets, taco cat, and pull it up. Okay, so these are all textual representations. If we just go back to the Project Euler slide, we'll see that the example palindrome was 9009 or 9009, and straight away you'll now see that whichever way we place those numbers, it's the same forwards or backwards. And we're looking for the product of 2-digit numbers. In other words, what happens when we multiply 2 3-digit numbers together. We want to find the largest palindrome. Okay, so what I've done for you is I've, as a first step, produced some code for you to describe this solution, and what you need to do is have a look at that, and I'm going to bring that up on the next slide, or you can have a look at it in the supplied downloads and play around with it. This is a brute force method, so I didn't attempt to make this efficient in any particular way. I just searched through looking for all the palindromes I could find, and then chose the largest one. I'd like you to examine the code and work out what is the first palindrome that this code finds. So you might want to run the code, maybe add some print statements to it or something like that to help you find them. I'd like you to work out how many iterations were needed to find the code. So how many times did we go around the loops in the code? And then to describe the steps needed to find it. Now in the download you'll find both the code file. You'll also find something called an initial insight, which is the answer to the final part here to describe the steps needed to find it. You'll find it useful to understand how I went about writing the code, and that's what the initial insight is. And from that you might be able to devise some steps in your own words. So what does the code look like? Well, here is the code. To start off with, I'm not going to say too much about it. I'm going to let you go and have a play first. I will come back to this in a few minutes. The important parts of the code here are we've got 2 for loops, so that's where you're going to be looking for your iterations. In order to help you count the number of iterations, I've put a variable in there called tests needed, which will increase on every iteration. You will see that there are some various calculations there to work out if there's a palindrome. In particular, there is underlined on the screen a function called isPalindrome, which is presented separately in the code file, which returns true if the supplied string is a palindrome. Okay, so you may find that useful to look at. There's also some code supplied that stores a palindrome called best palindrome, and this is a class. So you may want to go and have a look at that and understand how the 3-digit palindrome class stores palindromes to allow for comparisons and so on. Okay, I'll let you have a look at that code. In terms of the initial insight, here's a summary of it on the slide. This is what I was attempting to do. So prior to writing the code, I worked out these kind of main steps that I would want the code to be able to do. So when you write your steps about how the code works, I'd like you to be a little bit more technical language than I've described here. So here we've got a description of what I was intending to write. So it may not match the code exactly. So I thought, well, what's the simplest way I can solve the problem? And that is by using a brute force approach. I'm just going to search through every possible combination of 3-digit numbers and find the largest palindrome that's produced. The simplest way I could think of doing that was to have 2 loops, one for the first number and one for the second, and check all values to the second loop, or the nested loop, before we checked the ones on the outer loop. First of all, I need to check that each product to see whether it's a palindrome or not. And I can do this in a recursive way. So you'll find that the check for palindromes is a recursive function. That is to say, it calls itself. Then I'm going to check, and as part of that, we're checking to see whether the outer 2 items of the string are the same. Then we throw those away, and then we check whether the next 2 outer items are the same, and the next 2 until we end up with either an empty string or a single character. And if at any point the outer 2 characters don't match, then we say that this is not a palindrome. And we're then going to need to store the palindrome, and we'll need an ADT to do that. And what I've not included on the slide here is that obviously we'll need to check each palindrome we find to see whether we've found the largest one at that point. Okay, so if you're having a go at putting together solutions, pause the video now, because the next thing I'm going to do is go over the solutions with you. Okay, so let's proceed to the solutions. Let's just quickly revise what the questions were. What is the largest palindrome found? How many iterations were needed to find it? And describe the steps needed to find it. So the first palindrome found was 10201, and the way in which we could have found that is we could have modified the code to add a print statement at the point where the first palindrome was found. So probably inside that if statement, if we added a print in there, we could print out each palindrome as they were found, and we could make a note of the first palindrome that had been found. The next question was how many iterations were needed to find it. The number of iterations were 2 in part A, in loop A, and 901 in part B. So 2 in loop A, 901 in B. Now, I provided you with the test needed there as an example of how to count iterations. To get the answer I've given there, you'd obviously needed to modify that slightly to count the number of loops in A in addition. The final part of this was to explain what the code was doing. So precisely what's happening is here, the first loop's set to 100, so we're going through only the 3-digit numbers. And the second loop then runs 899 times, so between 100 and 999, to test all the 3-digit numbers. And the first time round, none of the cases are a palindrome. So the body is never executed, so we never get to that if statement. It's body. Then the first loop moves up to be 101, and the second loop to be 100. Again, on the first occurrence, this is not a palindrome now. B is set to 101, so we've got 101 times 101. And it now is a palindrome, and it's larger than 0. So this is the best so far, and this is stored. So that's what was done to find the first palindrome. Okay, let's move on to the next question. So I then produced a more efficient solution to the problem. Okay, and this time I've not provided you with initial insight. And the answer that you're going to need here is something similar to an initial insight. You're going to need to discuss why this solution is a bit more efficient. Now, to give you a bit of a help, you'll notice that in the code provided, I have given a little bit of explanation about what's going on in the code, but there is only one comment here, so it's still on you to read this fairly carefully to understand what's going on. So I'll give you a moment at this point before I proceed to sort of discuss the solutions and the insight required that made this more efficient. So give the video a pause now and then I'll continue. Okay, so how did this become more efficient? Let's start with the insight that I used to get that, and then I'll explain it a little bit further. So the insight here is the largest number should be somewhere around the product of the two largest 3-digit numbers. So we know from maths that the larger the numbers are that we're multiplying together, the larger the result will be. So previously we started with the two smallest numbers to try and find the largest palindrome. But clearly, if we start with the largest numbers, we're probably more likely to find the largest number first. So let's start at 999 and work backwards rather than working forwards as we did before. But we also need to decide when to stop. And what I suggest we need to do is we need to stop when the outer loop is smaller than the smallest value found for the largest palindrome so far. So when A drops below the smallest value found for B so far, then the chances are we've already explored all of the problem space we need to look at. And so we can gain efficiency by ignoring the, if you like, the duplicate numbers where A and B become reversed. So we can be fairly confident at this point that anything smaller will deliver a smaller product. How does that translate to the code? Well, it's a fairly direct translation if we look at the solution. So instead of starting the search at 100, we start instead at 999. And the key thing is, as I mentioned in the last slide, it reduces the search space. So it's the case that the largest product of the two numbers must be made by the largest two numbers. So we just need to find when the two largest factors satisfy the criteria to be a palindrome. Okay, so as you can see, we can often start by solving problems with something that is straightforward, or a solution that makes sense to us intuitively. And then we can look at that solution and think, well, what can we do to reduce the complexity, the number of comparisons, the number of iterations, etc. in the code. And often a way of doing it, as shown in this example, is to only search part of the search space. So we reduce the size of the loops by having an intuition about where the solution will be. Now, an important idea in computer science with problem solving is that often we don't particularly want an answer as such, so we don't want to know what the palindrome is, but we want to have some kind of truth value. Now, previously we already looked at some code which did that for us, so it told us whether a particular string was a palindrome. What I'd like you to do in this question is to reuse that code to add an additional criteria. And not just look for a string, but is this a string that is a factor of two 3-digit numbers? So given a string which contains something, is it a palindrome? And is that palindrome a factor of two 3-digit numbers? Now, we'll be able to, you can make use of the ideas that we've already seen in the code to solve this problem. Okay, and the solution is substantially less complicated than the code that I've shown you and given you to look at. The solution I've given, just to give you an idea, is 5 lines of code. So there's not much to write here, but you will now need to think and produce your own insight on how to solve this problem using similar ideas to those that we've seen already. Okay, so I'm going to let you pause the video here and have a go at the question. Okay, so let's move on to the solution. So this was my solution to the problem. I've taken the liberty here to add some comments to the specification of the operation to explain what it's doing. And generally speaking, if you are producing code, either professionally or part of a university course, you'll often be asked to provide comments. The structure I've used here is quite a computer sciencey way of doing things. So I'm specifying what the operation is, its inputs, its outputs, and a pre and post condition. I've structured the solution here as a function, and a decision function provides a true or false answer, as was probably reasonably obvious in the question that was stated. This is something definitely to watch out for if you're doing this as part of your degree course, as you may be asked for a decision problem, and it won't necessarily, questions won't necessarily say this needs to be a true or false answer, but as soon as you hear the word decision problem, you know it's going to be a Boolean result. So the initial insight I have here was that it's quite difficult to work out whether a string contains a number which is the product of two 3-digit numbers. But it's quite easy to generate all possible 3-digit numbers and see if that happens to be the string. So that was the solution that I chose to go with here. So I started with the same loops that were in the previous code. So as I previously mentioned, this is very much reusing the ideas that had already been shown. From that, I generated the palindromes, and I tested to see whether the products. I generated the products, and then I tested to see whether those products were palindromes. And if it was a palindrome, I tested to see whether it was the string that was provided. And if it was, then I found the result and I returned true. And if it wasn't, then I clearly hadn't found the result, so I returned false. So quite a straightforward way to do this. Now you might have tried to do this by, for example, turning the string into an integer and dividing it by all the numbers between 100 and 999 to see whether you had an integer result. And that would have worked as well. You would still need to do a test to see whether the string itself was a palindrome. But I think that would be a very equivalent solution to the one that I've provided here. And there may well be other solutions, but it's worth noting that trying to find the two numbers, the factors of a product is quite a tricky thing to do. So generally speaking, it's going to be something you have to search for rather than relying on a straightforward mathematical operation. So the next question is about big O notation, and big O notation is something that is very important in computer science, and indeed in programming in general, being aware of the efficiency of your algorithm is important. Big O notation describes the amount of complexity in your code, and if looking at this online, do be aware that different authors describe the complexity in terms of different units of complexity. So in some courses, some academic courses, you might be asked to look at the number of comparisons or the number of assignments or indeed the number of iterations of loops. And depending on what you're being asked to do, you'll find that you get different answers. So be very careful to read any question set carefully. It won't be a huge difference because Big O looks at the largest factor in any computation of time complexity. And that will often be the same no matter what the unit of complexity is. Here, all I want you to look at is the number of steps needed from your algorithm, or if you like, another way of putting this might be the number of iterations, and that will be good enough to give us a broad idea of what the big O is. Here, n should be the number of 3-digit numbers to be searched. Okay, so I'm going to give you a moment to look at this. Okay, so pause the video now. So moving on to the solution, let's briefly look at the code that I produced last time and ask how do we work out what the big O is. The important thing here, whatever the unit of computation is with this particular piece of code, the big O will be the same. If we were using assignments potentially could be less. I think it's the main thing to say here because of the way the code is set up. So we have a assignment on the outside here that is run once, and we have another assignment in here that could potentially be run multiple times, but because of the guard here with the if, or that is protecting it, it's going to be run less. In fact, it's going to be run exactly 2 times. So if our unit of computation was assignments, then the big O is going to be order 1. So it's only going to be at most 3 assignments that take place, and if the big O isn't in the, if the supplied string is not a palindrome, then it'll actually only be run once. So if you saw this, more likely you'd be asked what unit computation to be iterations through the code or comparisons. So we can see straight away that we're going to go through the loops fully here. So for every time there's a loop, so we've got n numbers to check, we've got another n numbers to check here, and we're going to do those comparisons here. So we've got n times n, and we've got potentially 2 comparisons to do here. So it's something like the time complexity is along the lines of 2n squared. Now in big O we get rid of any additional information to do with the size and just look at the largest factor, and the largest factor here is n squared. The 2 is obviously a fixed constant. So the result would always be n squared if the unit of comparison is a comparison, and if the unit of complexity was simply looking at the number of iterations, it's also n squared, because we've got n here and n here, so we've got n times n, which gives us n squared. In the solutions I provided a while loops version, which is xn squared, so it's very similar to n squared. It needs more conditions. The factor of x is higher than 1, so it's not quite the same, but it's more or less n order n squared. Okay, the next question. The code here uses an ADT, or abstract data type, called 3-digit palindrome. Some of you may recognise this as a class. I'm taking the computer science approach to this, which is to define this as a data type rather than as a class. And in particular, this makes use of a rather strangely named function called underscore underscore CMP underscore underscore. And if you're learning Python and problem solving in Python, this is quite a relevant thing to make sure you understand. Here's the code. Have a look at it, work out what's going on there. You might need to do a brief internet search to help you understand what this function is about. I'll pause the video now, and then I'll give you the solution. Okay, so if you've undertaken an internet search, hopefully you'll have found the definition that's on the slide now. And this is a special method in Python for using comparisons. So it allows us to implement some code that will be run when the developer uses the less than, equals, or greater than comparisons for our code. So we needed it here, or it was needed here, to allow 2 3-digit palindromes to be compared to each other. So if you are writing solutions in Python, you may well find that these special functions used from time to time. If you're not clear about what they are, you will find solutions for them very clearly on the internet that explains what's going on. But generally speaking, if you see a function which has 2 underscores before it and 2 underscores after it, it's one of these special functions. The next question, describe why a 3-digit palindrome is not restricted to palindromes of only 3-digit factors. Okay, so here I want you to look at the code and explain that this is not just used for integers. Now here's the code, and the comments here are potentially a bit misleading. You need to understand a little bit about how Python works, and in particular how types are assigned in Python. So if you are more used to using a statically typed language like Java, then you need to, at this point, have maybe an internet search to understand how a dynamically typed language like Python works, and then this will make sense. I will pause here again to allow you to work this out. Okay, so moving on to a solution. It's worth noting here that in the ADT, or indeed the class, there's no invariance, pre or post conditions, assert statements, if statements or otherwise to ensure that only integers are provided. So I've used a kind of a design by contract type approach here. I've stated it should be integers, but I have not tested it in any way. So it's worth realising that there's actually a wide variety of things that could be provided here. So moving on then, a more complex question for you to have a go at. I'd like you to try and solve the following problem. I've given this to you as a specification, so I said I want you to implement a function called find a palindrome that has inputs, which is a numerical range, and outputs should be the highest numerical palindrome which can be factored into the two numbers which are in the input range. Now, in order to solve this, do be aware that, as stated in the previous question, the provided 3-digit palindrome works for any integers. There's no restrictions there on them being 3 digits, so you could use it for any number of digits. So you'll find that previously used code useful here. You will also be able to use the pre-provided code with some modifications to solve this problem. Okay, so we've got a longish bit of code here. So my solution is about 15 lines of code. I've just counted it long, and it's very strongly based on the code using a while loop that we use for solving the 3-digit palindrome problem, with a few changes. So have a look at that code, see whether you can change it to meet the requirements of this new problem. And the second question here, my apologies, I've managed to leave a reference into the original materials that this was based on. Based on, can you write inputs, outputs, preconditions and postconditions using a more technical style? So what I'm looking for here for you to do is work out what the data types are for the inputs, for the out and the outputs, define a precondition, so that is to say what values, what are the restrictions on the inputs that you've specified, and write a postcondition that describes what the outputs should look like. Okay, so a slightly more technical version of what I've given you on the top of the slide here. Okay, I'm going to pause and then discuss the solution with you. Okay, so moving on to the solution. What was expected here, as I described in my sort of preview to this, was make use of the code that was provided to you already and modify it. So the previous while loop implementation of finding palindromes with three-digit factors, hard-coded the start and ends of the search loops. Here, you needed to take that code, put it into a function that took the range, the start and end range of the values to be looked at, and put those variables in where we previously had hard-coded variables. So those are the main changes that have taken place here. Hopefully you came up with something similar. In terms of describing the ADT, using inputs, outputs, preconditions and postconditions, here is the solution to that. So the inputs here are going to be integers, the outputs should be booleans. There are preconditions on here, so the start needs to be larger than or equal to 0, and the end needs to be larger than the start. If those preconditions aren't met, then the provided code won't work correctly, and that's what preconditions should be. They should be specifying the range of the input values that are acceptable to allow the code to work as expected. In the postcondition, I've provided a mathematical way of explaining what is going on. That is making use of the is palindrome predicate that was provided earlier to check that the result is palindrome, and explaining how that is constructed of the various values. Typically, if you are studying this, you'll find that different universities, different modules will tackle this in different ways. Some places may well require a very mathematical definition to these answers, perhaps more so than this one, and some may simply ask you to state in unambiguous English. So do check very carefully what you are being asked to do, because if maths is not your thing, and I appreciate that's true for many students studying computing, you may find this kind of complicated maths tricky to get your head around, and prefer to go down the route of the unambiguous English. The last question here is about invariance. When we have ADTs, so this is, if you like, the theoretical definition of the class, we often want to state rules that must always be met of the data held within that class or within the ADT over its whole lifetime. And these are what we call invariants. Now, with a three-digit palindrome, there are some invariants that we would like to enforce on these on this type of data type. So have a think about those, see if you can come up with any ideas, and then I will discuss the solution. So yes, just pause the video here. Okay, I'll now discuss the solution with you. So what are the invariants that are required? The main invariants to be described are relate to the way the functions work. So any value that is stored here, which is the product of the two numbers in the palindrome, in the three-digit palindrome ADT, must be a palindrome. If it is not, then clearly something has gone wrong. We also want to enforce the fact that the two main functions, get factor for A and get factor for B, should store the value which have been set. Okay, and that's what the other two invariants enforce. So the stored values are those which were set, and once stored, those values are always a palindrome. One final bonus question suggests an alternative strategy to that used in question 1 to search for palindromes that have three-digit factors. I've included this here as an exercise for you more than anything else. I've not provided code for this. I'll just pause here so you can have a think about what could be done. So the solution here, a less obvious way of doing this, we could generate palindromes, so we could generate palindromes that involve numbers, and then search for their factors to see if they have 3 digits. We already produced a little bit of code that worked in that kind of way on one of the previous questions and solutions. So with a bit of work you may well be able to implement this answer. Thank you for watching the video. I will keep an eye on the comments below. I may be able to answer a few things, but I'd also encourage you to answer any questions that any other watchers make if you know the answers to them. Thank you very much. I hope you found the video useful.